Linearization. Part 2, we are going to linearization, let's say, linearization. This is video part 2. And we are going to talk about Newton's method. Newton's method. Newton's method. Okay, let's see. What is Newton's method? Suppose we have x-axis, y-axis, and suppose we have a curve, a certain function. This curve, right? This is y equal f of x, and this curve cuts this x-axis at point R. This is the exact root of this function, right? Because it cuts the x-axis where this function is equal to 0, where y equal to 0. That's great. What we do, sometimes this exact R we can't find. So one of the methods we use is Newton's method, and it's very good method to find the root. We guess the initial method, initial root or initial estimate for this root. It's just guess. At this point we draw the tangent, right? The tangent, and simply we will have a root here, right? A root. Now this line, as we did in the previous video, is y equal linearized form of this root, right? Linearized form, and there is an error. Newton's method will minimize this error as we go further to 1 decimal place, 2 decimal places, 3, 4. As we go more, if we guess this point first, right, and then we do linear model for this point, we got L of x. Taking L of x equal to 0, it gives me this one here, which is the root of L of x, right? Taking this L of x equal to 0, that's good. Taking this equal to 0, it gives me this point. And then we do what? We linearize this point, right? And we go more L of x, another L of x, to get another point, to get another point, to get another point. So as we go more linearizing, each time we do that, we will be near to R, up to certain number of points after the decimal point. That's good. We call this method is a linear method. What is linear method? We found it as in the previous video as f of a plus f prime of a into x minus a. Taking this equal to 0, this means that f of a, or let me take this to the other side, right? Minus, let me leave this f prime of a over here, into x minus a equal minus f of a, and let's find x in terms of f of a and f prime of a. So x times f prime of a minus a f prime of a equal minus f of a. Let's take those to the other side. So x times f prime of a equal a f prime of a minus f of a. Let me divide both sides by same number, which is the derivative at a, in such a way that this derivative not equal to 0. This implies x equal a f prime, a only, right, minus f of a divided by f prime of a. We can find x by taking this linearizing equal to 0, so we can find from a, we can go further to R, and we can find x. Which is a minus f of a over f prime of a. Okay, we do what in this case? This initial guess, which is a, we start with this initial guess. Let's name it x node. And this second guess, let's name it x1. We got what? We got another formula, which is x1 equal x node, or x0, minus f of a over f prime of a. We said a is x node, so f of x node over f prime of x node. Taking a as x node or x0, and x as the second x we get from x node, which is x1. Let's generalize this formula. In general, xn plus 1 depends on x of the x becomes we find it before it minus f of xn over f prime of xn. This is, we call it a Newton's method to find the root more accurate. Okay, let's do an exercise. Let's do an exercise to show this, right? Suppose we have, okay, finalizing this formula as this. All right, let me take an example. Perform two steps of Newton's method in an attempt to find an approximation of the root of f of x, which is equal x minus sine x minus 1. Because if we do f of x equals 0 here, it might be hard to find the root, right? Taking this x minus sine x minus 1 equals 0, it will be hard to find x. What is x equals to? So we need Newton's method to find where this function cuts the x-axis, or where is the root of this function. He said taking x node as 3 as an initial guess. So he will give me the initial guess. I can start with, right? With n equals 0 in this case, right? With n equals 0 and x node equal 3, Newton's method becomes x1 equal x0 minus f of x0 over f prime of x0. So what we need to find is f of 0, right? F of x0. F of x node is f of 3. No, it's f of 3, which is equal, f of 3 is equal to 3 minus sine 3 minus 1, right? 3 minus sine 3 minus 1, which is 2 minus sine 3. 2 minus sine 3. Let's see how much is that. Okay, let us find this value equals to what? For sure we have to get to change this 3 is a radian, it's not degree. So 2 minus sine 3, 2 minus 3 sine, right? Equal. It's 1.8588. So up to 3 digits, let's say it's 1.53. It's f of 3 is equal to, up to 3 digits, 1.859. 8588. So it's 859 approximately up to 3 digits. Let's find the f prime. What is f prime of x? It's derivative of x, which is 1, minus derivative of sine x, which is cosine x, minus 1. Derivative of minus 1, 0. This means f prime of 3 is equal to what? F prime of 3 is 1 minus cosine 3, which is equal, again to calculator, radians, right? Clear? It's 1 minus 3 cosine 3. The answer is 1.9899. So it's approximately 1.990. So I found these two values, right? These two values. Now let me substitute these values in my formula, which is x1 equal x node, right? x1 we need equal x node, which is 3 minus f of x node, which is 1.859 divided by 1.990. The answer will be 3 minus this value. Okay, 3 minus this value,